Okay, today we're going to be looking at intersection of straight lines. I've got a couple of examples straight off to look at. When we're given the two equations y equals, well, our two ways of doing intersections, we're basically solving simultaneous equations. So it's either solving by elimination or by substitution. Here, because they're both y equals, I can do it by substitution. I can solve, I'll write it that way around, 5x minus 9 equals 2x plus 3. Move the 2x across to get 3x, move the minus 9 across to get 12, to get x is 4, and stick x is 4 into either of those. 8 plus 3 is 11, 20 minus 9 is also 11, self-checking, that's my common point there, that's all there is to it. This is also by substitution because I've got y equals, and so where y appears with that, I can replace it with a half x minus 2, so I can rewrite 3x and then plus, or 2y, I could just double that in my head really, to get x minus 4, and then minus 6 equals 0, so I've got 4x, move that across, equals 10, x is 10 over 4, 5 over 2, and stick that into either one of these, probably best into that one because it's y equals. I've got 5 over 4 minus 2, which is minus 8 quarters to get minus 3 quarters. And I can check it in that one as well. 3x is 15 over 2, 30 over 4, and then minus 2y is minus 6 over 4, to give me 24 over 4, and that is fine there. It all checks out, it all equals what it should do. The other way is G to C. If I've got different numbers of x's, different numbers of y's, then I suppose I could make one of them the subject because I've got equals naught here, but the numbers are still, I've still got fractions knocking around. I can potentially have fractional answers, but that'll come at the very end. What's best to do here is choose one to get rid of, let's say x, times this 1 by 3, 12x, minus 6y equals 21, times that 1 by 4, 12x minus 20y equals 0, and subtract them. Make sure I'm doing the right way around. 12 minus 12 goes out, minus 6 plus 20, 20 minus 6 is 14y, and then that way around equals 21. And make sure I'm getting the signs correct, and y is 21 over 14, y is 3 over 2. And stick that into either one of these now to get the x, so it's 4x, and then minus 2y is minus 2, lots of that, so minus 3 equals 7, and yet again x is 10 over 4, 5 over 2, so I've got 5 over 2 and 3 over 2. Checking that one, 3x is 15 over 2, 5y is 15 over 2, when I minus them I get 0, so we're good to go. This one had a picture, it's got an equation of a line 2y equals 6 minus x, it's got a point 8, 14, and it wants the shortest distance from the point to the line. Well, any shortest distance is now perpendicular, so I'm looking for the equation of the line that's perpendicular to this, that goes to 8, 14, find the intersection point, and then the shortest distance, do a bit of Pythagoras on those two things there. Okay, so I know that, for example, from this one, if I go 2y equals that, then y equals 3 minus a half x. So m1 minus a half, m2 plus 2. So I know that the equation of the line I'm after, y equals 2x plus c. Stick y is 14 in, x is 16 in, plus c. c is minus 2. So my equation is y equals 2x minus 2. And I need to know where that and this intersect. So I'm going to stick this thing into there because I've got y equals. So 2y, 4x minus 4 equals 6 minus x. Move it across, 5x equals 10. I'm going to move the minus 4 across, x is 2. And stick it into that, and y is 4 minus 2, y is 2 as well. So I'm going from x is 2 to 8, so I've gone along 6, and y has gone from 2 to 14, up 12, so my shortest distance is root 12 squared plus 6 squared, which is root 180. Right. which is going to be 6 root 5 is the exact answer there. Okay, so in that case there's lots going on. I'm using my perpendicular lines. I need the equation of the line there. I need where that line and this one intersect. X is 2, y is 2. I didn't actually check it in the other one. Did it satisfy this one? It does. 2y is 4, 6 minus x is 4, so it does. It satisfies both of them at this point here, so I'm happy with that. Another picture one. It says we're given two lines which make up two sides of a parallelogram, and we're given eventually this point here, which will be the other opposite vertex of the parallelogram. So I need to know where they intersect. So I'm going to do a little bit here to say that we're going to go either way around. It might be an idea to, well, I suppose I could make y the subject from this one. I can say that y equals, well, you know what, because I've got minus 2y, then there's a minus y equals minus 9 minus 2x. I can replace that into there by doubling it and say x minus 2y, x minus 18 minus 4x equals minus 9, x minus 4x is minus 3x, and then 18 minus 9 is 9, x equals minus 3, and then we've got this mess here. There's lots of minuses knocking around. So y equals 9 plus 2x is 9 minus 6, y equals 3. Check it in both of them. Let's have a look now. Minus 6 minus 3 is minus 9, so it satisfies both of them. That is the common point there. The equation of the other two sides. I mentioned it in a previous lesson that the best thing to do in this case, I could rewrite each of these as y equals, but I know, for example, the one parallel to this one, this little dotted line here that goes there, is going to be 2x minus y is something or other. Let's call it. I'm going to have two constants, so I'm going to call this one c1 so I don't get it confused with the next part here. And all I'm going to do is stick x is 2, y is 1 in. So I'm going to have 4 minus 1 equals c1, which is 3. So its equation is 2x minus y equals 3. That's an equation of that little line there. This longer one here, parallel to the x minus 2y is minus 9. I know it's going to be x minus 2y is another constant, c2. And all I'm going to do is stick in, yet again, x is 2, y is 1, and to get c2 is actually 0. So I've got x minus 2y is nothing, or x equals 2y, y equals a half x. Either thing like that. Okay. Last one, quite complicated this one here. I've got this diagram here with points A, B and C forming, well, looks like an isosceles triangle to be honest. I'm told that this line from A to L is perpendicular to BC, and similarly B to M is perpendicular to AC. I've got to try and find the equation of AL. Right. Before I can do that, I need to actually have the gradient of BC, then I can have the gradient of AL because they're perpendicular. So I've done a little dotted triangle here, so I can say that as B to C goes from 1 to 3, so I'll go along 2 and then down from 7 to 1, down 6. So my gradient, M1, the gradient of BC is minus, as you're going downwards, minus 6 over 2, which is minus 3, which means that M2, the gradient of the line I'm after, A to L, is the negative reciprocal, which is a third. So the equation of AL must involve y equals a third of x, x over 3, plus c. I know it goes to the point minus 2, 1, so I'm going to stick y is 1 in, and x is minus 2. So it's 1 and 2 thirds, c is 5 thirds. So now the equation is y equals, an equation is x over 3 plus 5 over 3, or 3y equals x add 5. Yeah, and that does the job there. For 1 mark, it says write down the equation of BM. Well, BM, well, A to C is a horizontal line, B to M is a vertical line. So it must, because it's vertical, must be x equals, and must be x equals 1 in this case, because the x coordinate is 1 there. Okay. So what it tells me, by the way, is later on, I'm to this point H there, I know that on H, since it's the intersection with this line, x equals 1, that part of the answer for H is 1, question mark. that the x coordinate must be equal to 1. And all I'm going to do is stick x is 1 into this thing and say y equals 1/3 plus 5/3 or 6/3 equals 2. So I've got h to the point 1, 2. I know that for part D, because it wants the area of triangle A to H to M, I know that M is the point, x is 1, because on that one, and y is 1. So if I think about what I've got here, from A to M, I've gone -2 to 1, so I've gone along by 3. So it wasn't isosceles, it just looked it. And then from H to M, I've gone down from 2 to 1, so I've gone down by 1. So it wants the area of the triangle, so area is 1/2 times 1 times 3, so it's 3/2, 1.5 squared units. And that's all there is to it.